So in this video, we're going to talk about graphs of what I'm going to call basic polynomial functions and then their translations. So I think the best way to explain this is if we take a field trip. Woo, let's take a virtual field trip. Come on. Okay, so here we are at desmos.com, which you should know is my favorite free graphing website on the internet. Okay, so I want to just explain to you a bunch of different graphs. So starting with x squared, so we all know what, well, hopefully we all know what x squared looks like. So it's parabola. This is the most basic version of a parabola that you can get to. Okay, so what I want to do is I want to compare this graph to x to the 4th, x to the 6th, x to the 8th, x to the 10th, because there's a pattern here. Okay, so starting with x to the 4th, check it out. Let me zoom in a little. So it looks very similar, right, to x squared. It's just like a little more flattened out, and then it's just a little bit narrower, right? Okay, cool. So let's see, I'll just zoom in just a little bit more so we can appreciate that. Okay, so now let's take a look at x to the 6th. Let's just keep going here. Okay, x to the 6th. So same deal, right? It's a little flatter than x to the 4th and a little narrower than x to the 4th. So let's take a look at x to the 8th. Oh my God. Okay, so x to the 8th, same thing, right? So it continues to get a little bit flatter on the bottom and then a little narrower on the inside. And so I want you just to notice like these points where all of these shapes intersect. This is always the point 1, 1 and negative 1, 1. And that makes sense, right? If you plug 1 into any of these, you're going to get 1. If you plug negative 1 into any of these, you're still going to get 1. So that's why they all go through that point. And then if you think about it, so x to the 4th, x to the 6th, x to the 8th, whatever other number besides 1, anything greater than 1 that you plug in, it's just going to like get much bigger with each higher power, right? And so what that means is that each number, kind of as we go up, it's getting plotted up higher and higher up on the y-axis, and that's why it's looking narrower on this part. And then any fraction, so anything below 1, between 0 and 1, is going to end up being a smaller number, depending, like the higher the exponent goes, it'll be a smaller number, which is why the bottom just looks flatter. But the practical way that you can kind of remember this is that, you know, the higher the power, it still looks very similar, right? It just gets more exaggerated in each direction. So if I just do this one more time for x to the 10th, same thing, right? So here's x to the 10th, it's just a little flatter and a little narrower again. So really, like all of these graphs, they kind of act the same, right? They all kind of look like parabolas. They just get a little flatter as you go. Okay, so let's contrast that then to odd powers. So now we have our old friend x to the 3rd here, so we all know this shape. So let's just contrast it then. What about x to the 5th? So we've kind of got like a similar thing happening here, right? It flattens out closer to 0. And then, so notice this is the point 1, negative 1, negative 1. So right, if I plug negative 1 and I just get negative 1, and this point is 1, 1. So after that, it starts to get like narrower after those points, right? So if I go to x to the 7th, so flattens out, gets narrower here, flattens out, and then gets narrower from here on out. So if I zoom out a little, you can see that more. And if I continue, flatter, narrower. So it just continues the pattern. And if I go to x to the 11th, it still does the same thing. So these still really maintain the same shape. They just get a little exaggerated as the power goes up. And I think this is a very powerful thing to know about just the basic shapes of polynomials. So now that we've examined some of the basic shapes of those graphs, let's talk about different ways that we can manipulate them. So if I were to multiply any one of those graphs by some number a, so what happens? So if the absolute value of a is greater than 1, then the graph ends up being something narrower. And when it's between 0 and 1, then the graph will be wider. So let's just very quickly examine what that means. So here's x to the 6th, and so 3x to the 6th. So just notice how now the 3 will make this graph narrower, and 1/2 makes it wider. Now what happens if I manipulate these numbers a step further by putting a negative in front of them? Well, if you know something about just how general translations work, then you would expect that if I put a -3 in front, it's just going to flip, right? It's just going to flip the direction of that graph. And if I do that again for x to the 5th, so just notice, so I've got 3x to the 5th, so that one gets narrower versus 1/2 x to the 5th gets wider than the original graph, right? And then again, if I were to put a negative in front of, say, -3x to the 5th, what will happen? The graph will just reverse itself. It'll like flip itself over, right? So, okay, that is that set of kind of manipulations to the graph. Now, the other thing that I want to touch on here is something I've talked about in a lot of other videos. So this form, we've seen, like if you've worked with parabolas or just other translations, this should be familiar to you. So I'm kind of making this video with the assumption you've seen translations before. So this -h is referring to translating the graph h units right. If this is plus h, then that's left, h units left. Okay, now the plus k, what does that mean? That means that you're going k units up, and if it's minus k, then you're going down k units. So all of that works the same. So what I want to do is I just want to draw some really approximate sketches just to kind of highlight, you know, how these translations work. I feel like this is something that we're already familiar with. So let's say that I've got x minus 5 to the 5th plus 3. So this is really the graph of x to the 5th, which we are familiar with, except how does it move? It moves, so let's see, I'll write this out. This is 5 units right, and then 3 units up. Okay, so the graph of x to the 5th, it kind of looks like x to the 3rd. And when we draw x to the 3rd, we typically start with a point at 0, 0. And then we kind of move out from there. So what I'm going to do is I'm going to move 5 units right, 4, 5, and up 3 units. So here is my starting point. And from here, now I'm just going to kind of go out one in each direction. So it's really going to follow a similar shape to x to the 3rd. But I just want to make, like when it gets closer to this centering point, I want to make the bottom look a little flatter. So let's see if I can do this. So let's make this, here's a little flatter bottom, and then just a little narrower in here. So this is like an approximation of the graph. Not perfect, but you know, you get the idea. Now what about this one? Again, I just want like an approximate idea of what's going on with this. The power of this is if you can look at this and say, oh, this is just this graph, it just makes your life a little bit easier, because I think a lot of times we look at functions like this and we think, oh man, this is something really crazy and I have no idea how this looks, and it gets really intimidating. But there's a code with a lot of these graphs, right? And I say, oh, this just looks kind of like a parabola with, you know, a few changes. So maybe pause here. Why don't you sketch this? Hit play when you think you've got it. Okay, so this is going to be a little bit narrower. So this is gonna open down because it's x to the 6th, right? So it kind of looks like a parabola, just like a flatter one. And so I said this is gonna be a little narrower. Then this is gonna move, left 1 and down 4. Okay, so we're just trying approximates here. If you're watching this video and you're like, I have no idea what you're talking about, how are you getting all of this? I've covered this in other videos, so I'll drop a link to that in the description. Okay, so normally my parabola would be here at 0, 0. My sort of parabola is a pseudo parabola. But what I need to do is I need to move this left 1 and down 1, 2, 3, 4. So this is where I'm going to start. Left 1, down 4. Okay, so from here, now I want to make sure that this opens down and it has like a flatter bottom, and then I want it to be a little bit narrower. So I'm just going to draw like an approximate here. So let's see, maybe I'll draw something like this and this. Okay, so like this, but with a flatter bottom. And that's a nice approximation of just what this graph looks like. So The point of this video is just to give you some intuition with these types of graphs. Okay, so that's it for this video. So I will see you guys in another one where we will continue talking about how to graph polynomials.